Okay, class. Today we are going to be going over polyatomic ions and how to write a formula for a compound involving a polyatomic ion. And here I have a list of polyatomic ions, and a polyatomic ion is just simply an ion that is made up of many atoms. So if you look at this per bromate, you can see that it is made up of one bromide and four oxygens, and you can see or one bromine and four oxygen. But the overall charge of this compound is a -1. And because it has a charge, we call it an ion. Because it is made up of many atoms, we call it a polyatomic. All right, so it's polyatomic, made up of many atoms, and it's also an ion because it has a charge. Okay, so we have to still make sure when we are using these, and we're going to use these in ionic compounds, because ionic compounds have ions. We have to make sure that we follow the same rules that we've been using, which is to make sure that the sum of our charges are equal to 0. And so we can still use the same cross technique that we have been using. So let's read this real quick. Now that we have a reference for many of the common polyatomic ions, let's look at how to name and write the chemical formulas for compounds that contain them. There are two main things to keep in mind. If a compound contains more than one polyatomic ion of the same type, we need to place parentheses around the ion's formula before using the subscript to indicate how many ions of that type are in the compound. And then second, the overall charge of the ionic compound must be neutral, or 0, which means the sum of the charges from the cations and the anions should add up to be 0. We use this rule to figure out the formula of an ionic compound when we know the charge of an anion and cation. This rule can also be useful for deducing the charge of an ion when the chemical formula for the ionic compound is known. So I'm going to give you some examples, and some of this is not new. Like, for instance, the sum of the charges should equal 0. Rule number 1, using the parentheses, that may be new. So let's look at an example involving calcium carbonate. Well, when we're looking at calcium carbonate, we know this is an ionic compound because there's no prefixes here. All right, you will also recognize that a polyatomic, you can recognize that you have a polyatomic by looking at the name. Most of the polyatomics end with the ending ATE or ITE. So if we look at our picture here, we can see that bromate, bromate, ite, ate, ate. So you can see that they all end in either ate or ite with very few exceptions. So if you're not sure whether you have a polyatomic, look at the end, and if you see that it has an ate or an ite, you can be very confident that it is a polyatomic ion involved in that, and then you know you have an ionic compound, and you must look at the charges. So what we're looking for is calcium carbonate. And so what we're going to need to know before we even show our work is what is the charge of calcium and what is the charge of carbonate. So let's go up to our list and let's find carbonate. And you will see carbonate is right here, CO3. All right, it's carbonate, CO3. And what is the charge? -2. So we're going to remember that. And then calcium, if we go to this one, we find calcium, and it is +2. So what we're going to do in the show your work section is we're going to assign the charges. And I'm going to make sure I reduce my font here a little bit so I don't have to change it too much. Move it to this here. So we're going to say that it is +2, and then the other one was -2. So calcium was +2. We looked that up on our periodic table. It's not something that you need to know, just something that you need to look up. And -2. And because the sum of the charges already equals 0, there's no need to do a cross technique. You write it just as it is. So you will write CaCO, and then we have to subscript the 3. All right, whoops, I didn't do that though. All right, and then subscript the 3. And that will be good. All right, so when the sum of the charges already equals 0 at the beginning, 2 plus -2, there's no need to do anything but just write the formula as it is. You don't need more than one of anything, so you just write it as it is. That's a very easy case. All right, let's do another one. When we look at the formula for calcium nitrate, okay, once again, we're going to have to know the charge of nitrate and calcium. So let's go find calcium, which we should already know. We just did that. Calcium is +2. All right. and nitrate is -1. All right, we can see that there. So nitrate is -1. So we're going to go put our charges in for calcium and nitrate. So calcium, we said, was a +2. So let's write that in, +2. And nitrate was a -1. And we'll move those to the right place. Now, we have a +2 and we have a -1. Now, do the sum of the charges equal 0? And the answer is no. 2 plus -1 does not equal 0. So we have to do the cross technique here, but we have to be careful when we have more than one polyatomic ion. So let's go back to our rules real quick and reference that real quick. On number 1, it says if the compound contains more than one polyatomic ion of the same type, we need to place a parentheses around the ion's formula before using a subscript to indicate how many ions. So anytime you have a polyatomic ion and the sum of the charges do not equal 0, it is a really good idea to go ahead and put a parentheses in. All right, so we'll put a parentheses and a close parentheses, and we'll move that over to the nitrate, and we'll make it large enough so that it looks like it's supposed to. There we go. And then we'll do this one. And so this is what the parentheses should look like. It should not be looking crazy. There we go. Everything is in the parentheses. And so that's what we're going to need to show, because we are going to show more than one nitrate, because the sum of the charges do not equal 0. So anytime you have to do the cross technique, make sure you put a parentheses on your formula. So then now we can do the cross technique. We go to the line, and we're going to move this over here, and we're going to say that we have 2 of those. So we'll do that real quick. So we have 2. And we'll move that. All right, and then we will say we get the other line. And I do want you to show the line. Some people are not doing that. Show the line. That's how you get points. And then you get a 1. All right, and we'll move that 1 over to calcium. So now all you have to do is write what you see in your picture. And in your picture, you see that you have 1 calcium. And then you have a parentheses, NO. Now make sure you subscript the 3. Subscript 3. All right, and then you can come back out. And then you're going to leave that parentheses. And then outside of the parentheses, you're going to subscript again 2. All right, and that would be how you answer that. So that is showing you that you have 2 of the NO3 ions. That's what it's showing. But you have to have that in a parentheses, otherwise it does not work. Okay, so make sure you show that parentheses. All right, so I hope that you can get these other 2 that I have here. They should be very similar to what you just saw in the example problems, and you can reference the example problems in your work. All you have to do is look at number 1 and look at number 2. I didn't do this from a student view, so these are very accessible to you right now. So thank you for watching, and please get this done. We will have a couple more problems for tomorrow as well. Thank you.